Alright guys, welcome to Math 0314. Today we're going to be working on section 7.1, square root property and completing the square. So the first thing is something we're familiar with, which is if we are asked to solve for an isolated variable, it doesn't matter that it's squared. We know how to approach this. We want to isolate the variable, so we'll divide through by 4 and get p squared equals 9 over 4. And we know how to get rid of square roots. We know how to get it squared by square rooting it. So we square root it, and this will leave me with 3 over 4 plus or minus, because, again, negative 3/4 times negative 3/4 is positive 9/4. And there you have it. So you just have to take the square root, isolate the term, and get rid of the exponent by taking the square root. And just remember, it's always going to be plus or minus. So here we have a situation that's trying to look a little bit more intimidating, but the approach is still the same. We're going to subtract 75 from both sides. We'll get 3x squared equals negative 75. We'll do the same thing as before. We'll divide through by 3. X squared equals negative 25, which can be a little intimidating, but we know that if we take the square root of both sides, we get x to be plus or minus 5i. Moving right along, we have another situation that, again, tries to look intimidating, but we know that we can take the square root of both of these, and we'll get w plus 3 equals plus or minus square root 20. Now, here's where we get to a point that we can do some interesting work here. We know square root 20 is square root 4 times square root 5. And we like that because we can break down square root 4 to 2 root 5. So, finishing up, all we have to do now is subtract 3, and w equals negative 3 plus or minus 2 root 5. Okay, so the big thing about this section is a process called completing the square, and the completing the square allows us to take on situations where we have x squared and x. In other words, situations where we're close to or even having a trinomial. And the way completing the square is essentially you take the middle term, you divide that by 2, and you square it. And later I'll show you why that's true. But in the meantime, we're going to say, what is n equal to? N is equal to this, so 12 divided by 2 is 6. 6 squared is 36. Okay? So negative 26, we take that number, we divide by 2, that gives me negative 13, and then I square it, which will give me n to be 169. 13 squared is 169. Notice that the back will always be positive, because you're going to square it, and hence the result will become positive. Letter C is trying to intimidate you with fractions, because when you divide by 2, 2 does not go into 11 evenly. But you do the same process, which will leave me with 121 over 4. So n is 121 over 4. And that's fine. It doesn't have to come out pretty. D is trying to scare you even more, but realize that when you divide by 2, all you're doing is multiplying by 1/2. So you just tack on a 2 in the denominator. This is nice because these will divide out, and you'll have 2 over 7. And again, square it. So if I square it, I get 4 over 49. So n is 4 over 49. Okay? And that's essentially the process. Okay? So 5 is what we're building up to, which is solved by completing the square. So let's talk about this for a second, of the intuition as to why we want to complete the square. So if you tried to factor x squared minus 6x plus 13, we know it wouldn't work. Because 13, there's no way you can take the factors of 13 and add or subtract them to 6. 13 is 1 and 13, because 13 is prime. There's no way you could add or subtract 1 and 13 and get to 6. So, what do we do? What do we do? Well, the notion behind completing the square is this. I said that if we take the value, right, and I said, let's call this term b, right? I said that if you divide by 2, and then, and then square it. So if I take this divide by 2, and then square it, this actually is the same thing as this, squared. So let's see if that's true. X squared plus bx plus, this is b squared over 4. I'm arguing that this is going to be the same thing as when this is FOILed. So let's FOIL x plus b over 2. And so when I FOIL this, I get x plus, now, we know from, let me just FOIL old school. So this is x, and x is x squared. X times b over 2 is going to be b over 2x. b over 2 times x is b over 2x. And b over 2 times b over 2 is b squared over 4. Now, because these are the same, when we add them together, it's just times 2, so this just becomes bx. Hence, this relationship is true. So all we have to do in this particular problem, let me rewrite it down here, x squared minus 6x plus 13, all I need to do is move 13 to the other side, and then complete the square. So that means just divide this by 2, which is negative 3, but I don't need to pay attention to the sign, because when I square it, it'll become positive, irrespective of the sign. So 6 divided by 2 is 3. 3 squared is 9. What you need to remember, though, is that I added a 9 to the problem. So if I add 9 to one side, I have to add 9 to the other, and that's the big part. This will become x minus 3 squared. Because what I'm arguing is that when you divide by 2, that will be the same thing as what's here. So dividing by 2, negative 6 divided by 2 is negative 3. Notice here the sign does matter, and that's going to equal to negative 13 plus 9, which is negative 4. So just to be clear here, I want you guys to realize that what I'm doing right here, this is the same thing as all of this. If you FOILed this, you would arrive here. Okay? Why do we want this? Because this is the same thing as this situation. We know that when we have it in this situation, all I have to do, take the square root. So I have to take the square root, I get x minus 3 equals plus or minus, now square root of negative 4 is 2i, and then we'll just move the 3 to the other side. So x is equal to 3 plus or minus 2i. And there you have it. Let's look at another situation. Now, when we look at this situation, what we want to realize is it's the same thing as this one, except this has a leading coefficient as 1. And notice in my proof, it also has a leading coefficient of 1. So I need to start this off with a leading coefficient of 1. So how can we make that 1? Well, we know if we just divide through by 2, we get m squared plus 5m equals 3 over 2, and now I have a leading coefficient as 1. So just divide through by whatever the leading coefficient is, and problem solved. Now, we want to complete the square. So this is trying to scare us, but we know that all we have to do is take this number, divide by 2, and square. So this would be 5 over 2 squared. I'll write it as such to show you the process isn't bad. And then what we do to one side, we have to do to the other. So we're here. Now, that will make this m squared plus 5m plus 25 over 4 equals to 3 over 2. And remember, this is 5 squared over 4, so this is still, 25 squared over 4, so it's still 25 squared over 4. We know that all of this becomes m plus 5 over 2, quantity squared. And what I'm going to do here is I'm going to multiply top and bottom by 2 so that I can get the same sort of thing on the other side. And so cleaning this up, we get m plus 5 over 2 squared. This is going to clean up to 31 over 4. So we're going to take the square root of both sides, which will give me m plus 5 over 2 equals plus or minus square root 31 over 2. Now let's think about this for a second. The reason this happens is I can't take the square root of 31, but I can take the square root of 4, which is 2. Okay. From here, I'm going to just simply subtract 5 over 2, and m equals negative 5 over 2 plus or minus square root 31 over 2. Or, if you prefer, negative 5 plus or minus square root 31 all over 2. And there's our answer. So we can see, even in the difficult situations, it's not that difficult to do this as long as you follow it through step by step. All right, so this I think is actually the last problem. Yeah. So on this one, I want you to go ahead and pause the video and try this on your own. This is just trying to look intimidating, and hopefully you've done that now. We can talk about it. So this is just written in a way that's all out of sorts. So you just put it back into sorts. So we'll distribute 2x. We want to get all the terms, all the let's say all the x terms on one side. So I'm going to subtract 6x over here. So 4x squared minus 26x equals negative 30. Now I want to complete the square, but I need a leading coefficient of 1. So notice I'm dividing through by 4. This will break down to 13 over 2x, and on this side we have negative 15 over 2. So now I'm ready to complete the square, which means I'm going to take 13 over 2. I'm going to divide by 2, which is 13 over 4, and then I'm going to square it. So I'm going to add that to the other side. All right, let's keep cleaning it up. So we're going to get x squared minus 13 over 2x plus, now 13 squared is 169, 4 squared is 16, that's going to equal to negative 15 over 2, plus 169 over 16. We're going to continue to clean this up, so this breaks down to x minus 13 over 4. Remember we said the same thing as this divided by 2, squared, is going to equal to negative 15 over 2 plus 169 over 16. So I need a common denominator, so I'm going to have to multiply top and bottom by 8. 8 times 15 is the same thing as what? 4 times 30, so 120. So just to be clear here, I rewrote 8 as 2 times 4 times 15. You know, 4 times 15, think of a clock, that's 60. 60 times 2 is 120. So it's negative 120 plus 169 over 16. This breaks down to x minus 13 over 4 squared equals to, I believe that's 49 over 16. And now when I take the square root, we get x minus 13 over 4 equals 7 over 4 plus or minus. And then I will add 13 over 4 to the other side, so I have 13 over 4 plus or minus 7 over 4. Now, we haven't had this emerge yet, but this situation is actually really nice because we can actually solve these out, right? These are actually, we can break these down. So this is going to become 20, 13, I'm running out of space here, this is going to become 20 over 4, which is 5. And this one is going to become 6 over 4, which breaks down to 3 over 2. So this one, we can actually get nice clean numbers as our final solutions. So there you have it, guys. It's just an issue of practicing, and you'll get comfortable with completing the square. So hopefully that makes sense, and I'll see you in the next math video.